Hello everybody, so in this video we're going to look at how to find the equation of a line in the form of r, which is any position on the line, minus a known position on the line, which we'll call a, crossed with the direction parallel to the line, which we'll call b. And this is shown in this diagram here, where this is the point on the line, this is the direction parallel to AR, parallel to the line, and R is any point on the line. Okay, so using these, because we know that B is parallel to AR, then AR, when it is crossed with B, we get 0. And we can work out AR as A to O plus O to R. So this will be equal to the vector A to O plus the vector O to R. And now we can make this a bit simpler because A to O is the same as negative O to A. So we can write A to R as being equal to O to R minus O to A. And we're told in the question that O to R is R here. So A to R will be R minus O to A, which is this one here. So minus A. Now all we need to do is substitute this expression for the vector A to R back into here. So we've got R minus A crossed with B to make 0. And this is what we were asked to show here. Okay? So now we can use this form to show this form, when we can say A crossed with B is equal to C. So what we're going to do is we're going to expand these brackets out. We'll have R crossed with B minus A crossed with B. And this will equal 0. And then we can move all of this to the right hand side. So R minus B is equal to A crossed with B. And we're told in the question that A crossed with B is equal to C. So we've got what we were asked to find. R crossed with B is equal to C. Okay? So these are two common forms of a vector equation of a line, and we need to remember these as they help us solve questions later on. Okay, so let's have a look at question 2. So in question 2, we've been given the vector equation of a line through points P and Q, where P is at 1, 3 and minus 2, and Q is at 4, minus 1 and 3. And we've been asked to give the equation of this line in the form R minus A crossed with B. So the first thing we need to do is we need to work out the direction vector B. We can take the direction vector as P to Q. So B in this case will be equal to P to Q, and this will equal P to O plus O to Q, which we know we can write as O to Q minus O to P. And O to Q is 4, negative 1 and 3. I find this a lot easier to use column vector form. So we'll say 4, negative 1 and 3 minus O to P, which is this vector. So 1, 3 and minus 2. Then we'll add or we'll subtract the common components. So 4 take away 1 gives us 3 in the I direction. Negative 1 take away 3 gives us negative 4 in the J direction. And 3 take away negative 2 gives us a positive 5 in the K direction. So this is the direction vector, 3, negative 4 and 5. And you can see in the question we've been given a point on the line, which we could use as either P, 1, 3 and negative 2, or we could use the point Q, 4, negative 1 and 3. So I'm going to use both. So we'll say for the first one, we'll have R minus point P, 1, 3, minus 2. And I'll put this in blocked brackets, crossed with the direction vector 3 minus 4 and 5. And that will equal 0. Alternatively, I could have used point B, and that would be r minus 4, negative 1 and 3, crossed with the same direction vector, 3 minus 4 and 5. And again, that equals 0. Okay? So either of these would be equally valid. So for part B, give your answer in the form r crossed with b equals c. Well, just a quick recap. We know r minus a crossed with b equals 0. So therefore, multiplying this out, r crossed with b must equal a crossed with b. And we've already got b, which is the direction vector here. So r crossed with 3 minus 4 and 5 will give us a, the position vector. I'm going to use point P. So 1, 3 and minus 2 crossed with the direction vector 3 minus 4 and 5. At this point, we need to cross these two vectors together. So to make some space, I'm just going to rub out this solution, and then we'll just blot this off. Okay, so if we're going to cross these two vectors together, we need to say that I, j and k, our first vector is 1, 3 and minus 2, the direction vector 3 minus 4 and 5, and we're going to cross these two together. So this will give us I, and we'll look at these four. So 3 minus 2, negative 4 and 5, minus j, and then we'll look at these four. So 1, 3, minus 2 and 5, plus k, and then we'll look at these four. So 1, 3, 3 and minus 4. And we'll work out the determinant of each 2 by 2 matrix. So we'll get 15 minus the positive 8, which will give us 7i. The 5 minus the negative 6, which gives us negative 11j. And then the negative 4 minus the 9, which gives us negative 13k. So now we can substitute this back into here. And we get r crossed with 3 minus 4 and 5 will equal 7, negative 11 and negative 13. Okay? So I hope this has given you an idea on how to write the vector equation of a line in the form r minus a crossed with b and r crossed with b equals c. If you did find this helpful, please like and subscribe, and you can download the full lesson and worksheet from my website, mrmathematics.com. Thanks for watching and take care.